Hi everybody. This is lesson 3 about the Schrodinger model, or the quantum mechanical model of the atom. So it's a little bit more complicated than the Bohr model. The Bohr model had shells, first shell, second shell, third shell, but this one has a more sophisticated sort of mean about it. Okay, so you'll be asked to show the orbital notation for where electrons fit into an atom. Okay, and it might end up looking like this. It'll say 1s and then 2s and then 2p and 3s and 3p, which might look familiar to you. And it'll have little arrows in there, which hopefully you recognize as being electrons. And you'll notice that at each one of these locations, one of the electrons has an up aspect to it. You can think of that as being a positive or a clockwise spin, and the other one has a counterclockwise spin. So there's an up and a down in the 1s, and then there's an up and a down electron in the 2s, and then remember Hund's rule, up, up, up with Hund's. So in the 2p, there's 1, 2, 3 boxes, there's 3 orbitals, and whoever filled this in put in 1 electron with an up in the first box, 1 electron with an up in the second, 1 electron with an up in the third, and then they went back and put a down, 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 and then they filled them in like this. Now, how do you get the order of this? How do you know that 1s comes first, and then 2s, and then 2p, and 3s? Well, to know that order, you can either look at the front of your packet, which has this diagram right here, or you can look at your simpler sketch, which has the arrows in it, and you can see first comes a 1s, then the 2s, 2p, 3s. You can see the order of this here. So that's the order you put electrons in. So I've done this for you. I've said the 1s goes here, the 2s is here, 2p, 3s, 3p, 4s, 3d, 4p. Let me double check that on my little packet of happiness here. 1s, 2s, 2p, 3s, 3p going up, up, up in energy. 4s, 3d, 4p, 4. Yep, I think I got it right. Okay, so often we show boxes here, but sometimes we just use lines. Depends on how lazy you're feeling. It doesn't really matter. Some people prefer the lines, and some people prefer the boxes. So these are in the same order: 1s, 2s, 2p, 3s, 3p, 4, like that. It goes in the same order. All right. So let's say that you are asked to figure out argon's electron configuration. Now you look at the periodic table, and it says argon has 18 protons in the nucleus. 18 protons in the nucleus, so 18 electrons in the shells, or that's the Bohr model, or 18 electrons in the electron configuration. So right here is where we do our work. 18 electrons. Stop me when I get to 18 electrons. The first electron I'll put in the 1s. I'm following the Aufbau principle. I'm giving it an up aspect. The second electron goes down like this. That's the Pauli exclusion principle. They have to be opposite. One up, one down. Not 2 ups, not 2 downs. An up and a down. And then after the 1s, we start putting electrons in the 2s. So we put it up there and a down. That's 4 electrons. We need 18. We got 14 left to go. The 2p, there's 1, 2, 3 boxes. There's 3 orbitals. So we go up, up, up with Hund's, and an up electron. That's 3 electrons. And then down, down, down. That's 4, 5, 6, giving us a grand total of 6 plus 2 plus 2 is 10. We need 8 more. We have to stop at 18. So 2, 4, 6, 8, 10, 11, 12, up 13, up 14, up 15, down 16, down 17, down 18, stop. 18 electrons. That, my dears, is the electron configuration for argon. Well, that's a lot of work, and we want to do this to sort of think about, very clearly what's going on here with electron configurations. But it's also kind of messy, takes a long time. So there's a shortcut method that you'll learn about, that we're learning about now, and you'll practice in class. And that is showing electron configurations by just drawing them out like this on the next slide. So let's consider carbon. So you look at carbon, and carbon has, 6 protons in the nucleus. 6 protons, 6 pluses in the nucleus, 6 electrons in the outside. So 6. You'd put 2 electrons in the 1s. If you had a box, an up and a down. The 2s has 1 box. You'd have an up electron and a down electron. That's 4. And then the 2p, 3 boxes there. Up, up, up with Huns. We need 2 more electrons. We have 1, 2, 3, 4. We need 6. So you go up and up. Well, you see you have 2 electrons in the 1s, 2 electrons in the 2s, and 2 electrons in the 2p. So what's the shorthand way to write it without making the boxes? You write 1s2. 2 refers to 2 electrons. 2s2, don't say squared. 2s2, there's 2 electrons in the 2s. And 2p2, there's 2 electrons here. And either one of these is an electron configuration for carbon. Another example here. The electron configuration of boron, it has 5 protons, therefore 5 electrons. It's 1s2, 2s2, 2p1. It comes right before carbon. So stop at 2p1. That's 5 electrons. 1, 2, 3, 4, 5. Yep. Okay, how many electrons are in this atom? 2 plus 2 plus 1 is 5. What's the atomic number for boron? It must be 5 as well. The number of protons is 5. Write the electron configurations for nitrogen, all right? Look at the periodic table and you see nitrogen has 7 protons. So stop me when I hit 7. 1s, I can fit 2 electrons in there. What comes after the 1s? The 2s. How many electrons can fit in there? There's 1 box, so only 2 electrons can fit in there. So we have 2 plus 2 is 4. We need 3 more electrons. 1s2, 2s2. What comes after the 2s? It's the 2p. How many electrons can fit into all those 3 boxes, those 3 orbitals of the p's? 6 electrons. We don't need 6. We only need, we have 2, but we have 4 so far. We need 7. We need 3 more. So can you fit 3 electrons into the 2p, which would look like this? Yeah, sure. You could fit 1 up, 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 down, down, down. You could fit 6 in there. We only need 3 more. So 2p3, you're done. Let's try magnesium. Magnesium has 12. 12 Mg has 12 protons. Stop me when I hit 12. Maybe I'll use this to help me. I'll use my worksheet to help me out. 1s2, 2s2 electrons. That's 4 so far. 2p6, I'm getting close. 2 plus 2 is 4, plus 6 is 10. I need 2 more. What comes after the 2p? Let me look. After the 2p, after 2, 3s. 3s. Can I fit 2 electrons in the 3s? That's 1 box. All the s's have only 1 box. Can I fit 2 electrons in there? Yes, I can, and up and a down. So I say 3s, 2, and I'm done. How about chromium? That's a little bit tougher. Chromium, so 24. Cr has 24 protons. 1s2, 2s2, 2p6, 3s2. We're at 12 so far. We need 24. We're halfway there. What comes after the 3s? After the 3s comes the 3p. After the 3s, I'm looking right here at my cheat chart. 3p6. And then after the 3p comes the 4s. 4s, I can only put 2 electrons in there so far. Let me count up, see how many I have. 2, 4, 10, 12, 18, 19, 20. I need 24. What comes after the 4s? I need 4 more. After the 4s, after the 4s, after the 4s comes a 3d. 3d. Now d's can hold up to, there are 5 boxes, remember. They can hold up to 10 electrons. I only need 4 more. Can I fit 4 into a 3d? That is to say, look back, and d's look like that. You can fit 2, 4, 6, 8, 10 electrons in there. I only need 4 more. Can I fit 4? Yep, I would go up, 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 stop. 1, 2, 3, 4 electrons. 3d4 is the shorthand way to write this. So chromium's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Count 24 electrons. If you do that, you'll understand what a shortcut electron configuration is.